Welcome to the Design Concrete Formwork Suspended Slabs tutorial. This video discusses the Suspended Slabs page of the DesignConcreteFormwork.com as well as outlet pages of the Suspended Slab Formwork Design Facilitator. To access Suspended Slab Formwork, log on to your account as usual. Note here the different types of design form types, suspended slabs and walls. To access an existing suspended slab, simply select Design Project. Select Project Design. New suspended slabs can be added as well back in the projects area, and we'll go over that towards the end and add a new scenario. But for this scenario, in this project, note the existing project data that comes over: suspended slab length, width, thickness, and slab heights. On this particular project, there's only one scenario. Let's edit this existing scenario. We'll do that by pushing the Edit button. And let's review all of the different categories and information that you can use to customize your particular pour. There's additional live load, which defaults to 50 pounds per square foot. Rental period in months. This, like the wall formwork, pertains to how long your project will go, and as it selects material, will analyze whether you should rent or purchase material items. Maximum deflection, self-explanatory, multiple items. Carpenter wage. Carpenter wage pertains to the labor portion only of setting and removing shoring. The production rate is given over in the shoring portion of the material library. Under miscellaneous options, there's load-bearing width and load-bearing along length. These options allow for a ledger around the wall perimeter to take form load, and if you select these options, your formwork system will be cheaper because there will be typically fewer shores and fewer stringers. But of course, there will also be more labor involved in setting the ledgers. Optimal joist orientation. Forced joist parallel to length, forced joist parallel to width. Optimal joist orientation considers both orientations of the joist, whether it goes lengthwise or widthwise. Conversely, you can force the joist to go one way or another by selecting one or two of these options. Shore frame selected. Force frame parallel to stringer, and if shore frame selected, force frame parallel to joist. This option allows you to specify which way you would like your joist to run parallel, your stringers to run parallel to relative to the joist, if in fact your shore frame is selected. Under material constraints, as always, you can go back and select individual items of what you would like. And let's go with some post on this. So these are constraints that we're going to put in this particular case. Alright, let's update our input. Okay. So now we're ready to calculate. Notice these other two options. Delete slab scenario, which is self-explanatory. It'll ask you to confirm deletion prior to deleting it. In this case, we don't want to delete. And then add new slab scenario, which we'll go over here in just a second. But for now, let's calculate the results of what we just entered. So press calculate design. Notice this piece of information here. So post is too short, too tall, or frame size is too big relative to the combination of joy string capacities. So let's go back and see what happened. Here's the problem. Note that our slab height is only 8 feet, but our shoring post is 6.5 feet maximum. So let's go back and edit that. And let's put in a 10.5 foot. Okay. We're updating. Now we're going to calculate again. And here's our solution. Note that there were two solutions analyzed. That was for the joist locations running either lengthways or widthways. Note the legend for the material selected. These, in this case, since all these were predefined, are going to list what we put in. So the legend for the sheathing is in black. So everything in black pertains to the sheathing. That's what's in actual contact with the concrete. There are the joists, which in this case are 4x6 double Douglas fir. There's green, which are the stringers. That's a 7.5 inch alumina system. And the shoring posts by the red dots are 10.5 feet tall. So in this scenario, note also that there are no end supports in this example. So we looked at two different solutions as discussed earlier, and our total unit cost is $2.88. So let's go back and see how a new scenario would look if we had no constraints. So we're going to add a new scenario. Okay. We'll put in a title of no constraints. And everything else will leave the same, except in this case we'll have no constraints. So we'll insert that option. Notice now you have two different scenarios from which to choose from. This is scenario number 2. So let's calculate the cost. Note the last time is $2.88. Wow, look at that, 82 cents per square foot. And there's 3,240 different combinations analyzed, and this here is our solution. Okay, let's look at one more option and then we'll go look at the print solution in detail. Let's add load bearing along width and load bearing along length and see how that impacts our solution. So we'll go in edit mode, check the two options, we'll update, and now we'll go calculate. So notice the dotted line around the perimeter is designating supported ends. You can see that the formwork system is less now, but our cost went from 88 cents a square foot, I believe it was, down to 79 cents. Not a big difference, but something that you may want to consider on one of your designs. Let's take a look at the print solution in detail now. So we'll click that. We'll generate a PDF. Note that there's a couple different options on your output. And there's our solution. There's our printout. So certain information about your particular project. This is what you're using. This is a buy. These are rental options here. Here's an actual hard printout of what the system looks like. And here on the next page you have all the constraint locations on how to build it. All the different elements. But the last page is a list of the constraints. Alright, we'll go back. Let's close this window, cancel, and let's go back to return. Let's briefly add a new scenario. To do that, this concludes our suspended slab form designs facilitator for design concrete formwork. For more information on projects, material libraries, or wall slabs, please see those related video tutorials. Thank you.